Hi students, in this video we are going to discuss about the filtering of long data sequence. Normally in real-time application, when an input is given to a system, you know that the output obtained will be the convolution of input and the impulse response of the system. In the real case, we know that the input should be of not a finite duration. Suppose I am speaking in a mic, okay? So what the mic will do, it will amplify the speech of the speaker. The speech of the speaker is continuous time. So we may not able to wait for the speaker up to where he complete his speech, then we may not able to perform the amplification operation. So if we do in this way, it may not a real-time operation. So what we can do is, in this case, the input sequence, right, this is an infinite sequence. It will not end up for particular time duration. It is of infinite duration sequence. So in this case, what we have to do is, we have to split the input into blocks. What we have to do is, we have to split the input into blocks, and we have to do convolution for that block. So for each block you will have n convolution. Suppose you are having n blocks, you have n convolution results. So finally we are going to merge the results. So in order to do this, you are going to choose two methods. One is overlap add method and overlap save method. We will see these details, algorithms in details. The next case, you know that if you want to obtain the output, either you can perform convolution and we can obtain the output, or what we have to do is, we have to perform any transformation. Since it is a discrete time, what we are doing is, we are going to use a DFT. Then and similarly we are going to perform DFT for a impulse response h of k. Then finally we are going to obtain the y of k, which is nothing but x of k into h of k. Then we are going to take inverse DFT for this sequence. For this y, you will obtain y of t. So this is the another procedure. First procedure is using DFT. Another procedure is using convolution, that is y of n is equal to x of n convolution h of n. Now here what we are going to do is, we are going to deal with the periodic signal. So we are going to concentrate on circular convolution, right? Now we will discuss about overlap save method, how we can implement this overlap save method. Consider I am having the length of the sequence is 15 and the impulse response of the sequence is 3. Okay, so what we have to do is, first I am going to assume, this is the assumption, we am going to divide the 15 input sequence into 5 blocks. You can take any assumption in this case. Okay, so what I am going to do is, I am going to take 5 input sequence. So what I am going to do is, first I am going to consider x1 of n. So x1 of n, in this, the length of the x1 of n should be 5. Okay, which is nothing but your n. In this n, what are all the things you need to consider is, you need the input sequence as well as the appending. We are going to append zeros. Okay, so here how we need to append zeros is, we need to append m-1 zeros. So m is nothing but the impulse response of the length of the impulse response. In this case, what I have assumed is, the impulse response is 3, so it is 2. So I am going to append 2 zeros before. After that, I am going to, in this totally 5 sequence, if I have appended 2 zeros, the remaining thing is 3 sequence I need to get. That I am going to get from the input sequence, that is x of 0, x of 1 and x of 2. Similarly, here I am going to proceed until I have completely taken all the sequence. So only for the first sequence in overlap save method we need to append zeros. For the remaining sequence, these first two sequence should be the last two sequence of the previous block. So here I have taken like this. Similarly here x4 x5, here x4 x5. Similarly you need to complete until all the blocks, until you have taken all the inputs in the input sequence. Then what we need to do is, finally we need to perform the convolution result. That is, we need to obtain the output of the system. So in this case, either you can use DFT procedure or convolution procedure. In DFT procedure, what I am going to do is, in here I am going to use convolution procedure. Here they have not mentioned any procedure, so I am going to use convolution procedure. Here I am going to use the circular convolution because I have assumed that here this is a periodic sequence. So x1 of n convolution h of n. So here the length of the two sequences are 5. Here the x of n is 5 according to this problem. Therefore h1 of n should be 5 in order to perform circular convolution. So in this case the length of the impulse response is 3. So we need to append zeros. So you will get the 5 output sequence. So similarly, you need to perform output you need to find out the output for all the sequences. So finally, what we need to do is here, because we have inserted zeros and we have used the previous input sequence, right? So we need to finally discard the first two sequences and we have to write down the remaining sequences. So this is the procedure to find out the output using overlap save method. Now I will explain this overlap save method using one problem, then only able to understand this. Consider this is x of n. Here I am having how many sequence? 1, 2, 3, 4, 5, 6. 10 sequence I am having. Here the impulse response of the sequence is length of the impulse response is 3. So what I have to choose here, m should be 3, which is nothing but the length of the impulse response, and the block size n should be greater than n. So how I am going to choose n is, I am going to assume that n is equal to m minus plus l. So m minus 1 is nothing but zeros. How many zeros we are going to append? So plus L. So if I have assumed the size of the block is 5, so I am taking L as 3 sequence. If I assume the size of the block is 6, I need to take 4 sequence. Like that you can do it. Okay. So it depends upon the input how we are getting frequently. So that it based on that real time condition. So here in problem we have taken L is equal to 3. Okay, so first x1 of n is equal to, first what you need to do, we need to add m minus 1 zeros. So I have add 2 zeros and I have taken first 3 sequence, 3 minus 1 0. So this is L is equal to 3 data points. Next one is x2 of n. What I need to do in this case, I need to take the last 2 sequence of the previous data. So minus 1 0 plus next 3 sequence 1 3 2 I have taken. Okay, I have completed x2 of n. Similarly, I have to do x3 of n and I have to do for x4 of n. While doing x4 of n, I have taken 1 and 2 from the previous block. Here I only one input is there. So in order to have equal length, I have appended zeros at last. This is the thing you need to consider while splitting the input into number of blocks. So I have already told that in order to obtain, either you can use convolution method or a DFT method. Because the convolution method is circular convolution method is very simple, we use this method. So y1 of n is nothing but x1 of n convolution h of n. In this convolution, what we need to do, we need to keep one sequence as such and we have to shift the sequence. So this is what your impulse response. In order to make both lengths equal, I have appended zeros here. So 1 1 1 0 0 is the in sequence that is the impulse response of the system. Now I am going to perform shifting. Already we have familiar with the circular convolution. Just I have performed circular convolution for impulse response and x1 of n. I have obtained this results. So finally I have done for all this sequence. So here totally how many sequence we have obtained? We have obtained 4 sequence. So I have obtained 4 different output. So I have obtained 4 different output. In this case, we have appended zeros and we have used the previous 2 sequence. So what I am going to do is, I am going to discard the first 2 sequence because here I have appended zeros. Here I have used 2 sequence from the previous data. Here also I have used 2 sequence from the previous data. So discarding the first 2 sequence, what I got is, I got this answer y of n. Hope you have understand the overlap save method. When you solve problems, you are familiar with these type of procedures. Thank you.